Hello everyone. In this video we're going to be going over the Vieta's formulas. As I mentioned earlier, I prepared some examples for you to solve. Okay, so let's go ahead and take a look. Vieta is a French mathematician. He introduced some really cool stuff into algebra, and his formulas are basically formulas that relate the coefficients of a polynomial to the sums and products. Okay, so let's get started with the formulas. First, I'm going to go ahead and introduce you to formulas in some basic cases, and of course this can always be generalized. So let's take a look at these two cases first. So if we have an equation that is quadratic, like ax squared plus bx plus c, suppose the roots are x1 and x2, and we could name them p and q, m and n, doesn't really matter. But what matters is that without actually solving this problem with the formula, we can find the sum of the roots and the product of the roots, and those are given by these two formulas. They are super important. Time to time I use them in the videos, like for example, we'll get the equation of a circle and then one of the solutions is going to be negative. How can I tell? By looking at the product and the sum. Okay, so these are very helpful formulas. So basically, and this is true for any degree polynomial equation, that the sum of the roots is always going to be negative b over a. This never changes. And then what happens is with the product, we get c over a, and then we get negative d over a, so on and so forth. It just alternates, but it always starts off with negative b over a. For example, if it's a cubic equation like this one here, if you're dealing with a cubic equation, then the product of the roots is going to have a negative sign in front of it. In other words, we do have something called the negative 1 to the power n, which accompanies the product. So let's say we're using a z over a here. If the degree of the polynomial is even, like the quadratic, then the product will have a positive sign. If it's cubic, which is odd, then it's going to have a minus sign in front of it. That's kind of how you can remember how to do the product. Okay, awesome. So this is kind of nice. And with the cubic equation, you kind of see the different variations. For example, we have x1 plus x2 plus x3, and then we have the two-way products, and then their sum is c over a, and then the product is going to be negative d over a. So let's go ahead and take a look at these examples. Without further ado, I prepared some problems for you guys, and these are all basically, I just wrote them from scratch, pretty much. Okay, the roots of this equation are x1 and x2. So we're going to start simple to get the main idea, and then I'm going to go into harder problems. Okay, so it's asking for two things here. So this problem has two parts. Let's go ahead and calculate this first. Since this is quadratic, I can just go ahead and, find x1 plus x2, which is definitely going to be helpful. It's negative b over a. Negative b means the opposite of b. In this case, it will be 4 over 1. But when a is 1, you don't even have to worry about it. You can basically say that the sum of the roots is just negative b. Okay, most cases, a is going to be 1, and you can safely say that the sum is negative b, the product is c. Okay, cool. So in this case, the sum is going to be 4, and the product is going to be 1. Awesome. Once we know those, let's go ahead and look at these two parts. Part A, now as it is, this problem is not very good. So what I'm going to do is I'm going to distribute 4x1, x2, and then I'll get 6x1 plus 6x2 plus 9. What I'd like to do here is organize this a little bit so that I can use my formulas, so that I can take out 6 here, and then I'll be getting this. Obviously, the rest is easy because I know what x1 plus x2 is, right? So I can just go ahead and plug this in here. This is going to be 1, and this is going to be 4, and the rest is easy because it's going to be 4 plus 24, which is 28, plus 9 is going to be 37. Okay, the rest is just computation, all right? So don't worry about that part too much. So let's go ahead and take a look at part B here. For part B, what I'd like to do is I'd like to make a common denominator. That's going to give me x2 plus x1 divided by x1 times x2. Obviously, we know that the sum is equal to 4 and the product is equal to 1. So this is going to equal 4. So basically, by knowing the basics like sum and product, I can evaluate different kinds of expression. All right, let's go ahead and look at problem number 2. Okay, and I try to pick different levels of problems here, so hopefully you'll get a good variety. And please let me know what you think in the comment section about this video. Any comment or suggestion is actually appreciated. Okay, so we have an equation that's given as 2x squared minus 7x plus p squared plus q squared is equal to 0. the roots are p and q, and root is just another word for solution. Find an equation that relates p and q. So it was kind of hard to word this problem, so I just wanted to, make it kind of vague, because if I ask for something specific, it'll be more clear, the solution method. So anyways, well, what do I know? Before I look at the question, like what are they asking for, I'd like to do the two things, sum of the roots and a product of the roots. Obviously, the roots are p and q, so p plus q is going to equal negative b over a. In this case, we have an a that's not 1, so it's going to be 7 over 2, which is nice, okay? What about the product? Okay, the product is going to be pq, and that is equal to c over a, which is p squared plus q squared divided by 2. So this is kind of interesting, because we know that the roots are p and q, but the equation also contains p and q in them. So that's what makes this problem kind of interesting. Okay, so what am I going to do with this? Like, I don't really have anything to base this upon, because, okay, fine, I know p plus q. Well, can I just get square both sides? I can get, I can just go ahead and square both sides. That'll give me p squared plus 2pq plus q squared is equal to 49 over 4. And then what I can do is I can just go ahead and replace p squared plus q squared with 2pq. Then I'll get to pq, but then pq is equal to that, so on and so forth. Anyways, you can definitely do it that way, but I have a different approach. And that is actually really cool. I really like this problem for that reason. I'm going to cross multiply this here. So p squared plus q squared is going to be 2pq. And then what I'd like to do is, this is kind of like a quadratic equation, but I'd like to get everything on the same side. So it's going to look like this. And what does this look like to you? I mean, this is obviously a perfect square, isn't it? And this perfect square can be written as p minus q quantity squared. And this implies that p minus q is equal to 0. And what is that supposed to mean? It means that the roots are equal, discriminant is 0. I was going to ask for discriminant first, but then I thought maybe this is a more interesting way to ask the question, and p equals q. Remember that we were looking for an equation that relates p and q, and we got it. The answer is p equals q. They are equal. All right, awesome. Let's look at number 3. Now, here I gave you a little bit of more information, because we do need to know, and again, this can be proven easily, and Vieta obviously supports this too. The equation whose roots are given can also be written. So if I tell you, okay, I have an equation whose solution is 2 and 5, then you can safely say that, hey, this equation is going to be like that, right? Right away, you can write the equation. Or if I gave you the equation, you could just factor and solve it, vice versa. Okay, cool. Now, what am I going to do here? Well, if the roots are m and n, I can call this m, right? So let's call this m. M is x1 over x2. And n is, actually, no, that's not right. Nope. The roots are, well, let's see. Yep, exactly. That's actually accurate. M is equal to x1 over x2. I thought for a second, like, am I doing the right thing? Okay. N is equal to this. So what I need to do is, from here, I do need the sum of m and n, and I need their product. Okay? So that I can write the equation from this formula. So what is m plus n? Let's do it. Okay, m plus n is going to equal x1 over x2 plus x2 over x1. Now, this needs to be worked out. Making a common denominator, you realize you get x1 squared plus x2 squared divided by x1, x2. Now, I do know x1, x2 from this equation, by the way, right? So I didn't write that down. So let's go ahead and write it down here. From this equation, I do know that x1 plus x2 is equal to 6. And x1 times x2 is equal to 10. Why? Because x1 and x2 are roots of this equation. Therefore, I can just write that down. And what is so good about that is I'm going to use them here. Great. Awesome. So now, what am I going to do for the top? Well, the top can be written using a little algebra. I can write it as x1 plus x2 quantity squared minus 2x1 x2 divided by x1, x2. And now I have everything I need. x1 plus x2 is equal to 6. So this will be 6 squared minus 2 times 10 divided by 10. And that'll be 36 minus 20, which is 16 over 10. And that'll be 8/5. So that's going to be the first part of my equation. Well, what does this give me? It gives me m plus n. But notice that I'm going to need that to write my equation, but I also need something else, which is m times n. But you're going to realize that m times n is actually like super easy, because what happens is, of course, these values are not 0. They cancel out, leaving us with mn equals 1, which is nice because now I got the value of mn, I got the value of m plus n, and if you remember, the equation can be written like this. Therefore, I'm just going to go ahead and use this formula. So the equation whose roots are m and n can be written like this. What I'd like to do is I'm going to basically replace the m plus n with 8 over 5 and mn with 1. And this is going to be my equation. If you don't like the fraction, you can go ahead and multiply everything by 5 and you'll get a nicer version. And this is going to be the answer. All right? All right, cool. Let's go on to the next problem, number 4. All right, the roots of the equation form an arithmetic sequence. Again, I try to give you a different variety here. What is that supposed to mean? If the roots of a cubic equation form an arithmetic sequence, if the roots are x1, x2, and x3 in numerical order, then you can safely say that this is the same distance from x1 and x3, which also means that x2 is the average of x1 and x3. That's what makes an arithmetic sequence, right? And this in turn means that x1 plus x3 can be written as 2x2. So now what is so good about this? Well, you're going to realize what is so good about this when we go ahead and write down the relationships. In other words, Vieta's formulas. What are they? Well, for the cubic equation, I do have x1 plus x2 plus x3, which is negative b over a, but a is 1, so we can just say negative b, which is 6. Now, we don't really need to go into the other equations because this is enough. Why? As you can see here, in this equation, I have x1 plus x3. So what I can do is I can replace x1 plus x3 with 2x2, and then I'll have an extra x2 here, which gives me 3x2 is equal to 6 and x2 is equal to 2. So I was able to find one of the solutions of this equation, and what I can do is I can just plug it in because this is supposed to satisfy the equation if it's a root, right? So let's go ahead and plug it in. If x is equal to 2, then we'll be getting 2 cubed, which is 8, minus 6 times 2 squared, which is 6 times 4, which is 24, plus 2m plus 2 is equal to 0. So what I'd like to do is solve this problem, and I have little room left, so let's go ahead and do it efficiently. 2m, so I'm going to be getting 10 minus 24, which is negative 14, but it's going to be on the other side, a positive 14, and from here, I'll be getting m equals 7, which is what I was trying to find. Okay, awesome. Number 5, let's take a look. Okay, now this problem is fairly interesting because it involves the sum of the square roots of the roots, or the square roots of the solutions, which is fairly interesting. I really like this problem, and I kind of had to tweak it a little bit to make it work because sometimes you get complex values and it's problematic because you know that a complex number has more than one square root. Awesome, let's get started. Now, what am I supposed to do? Well, I can write a couple things here. What am I going to do? Okay, so I can write the sum, which is 9, right? And then I can write the product, which is two-way products, x1, x2, x1, x3, and x2, x3. Remember, it's negative b over a, c over a. So that's going to be a 24. And then I can write the product as well, which is going to be negative, positive, negative, but it's already negative, so that's going to make it positive. So I have these three quantities that I can use for my expression. Nice. But here's the problem. I just have radicals, so what am I going to do? When you don't know what to do, call that something. Okay, let's call this guy here u. Yep, it is u. What happens if I call that u? Well, some nice things happen if you square both sides. Why? Because then you'll get rid of some of the radicals. Not all of them, but at least some of them. Let's go ahead and square both sides. And when we do, we should be getting a plus b plus c squared. So that is a squared plus b squared plus c squared. This should be longer. Plus 2ab, so that's going to give you this one. And then plus 2ac, it's going to give you this one. Plus 2bc is going to give you this one. All right, so this is equal to u squared. I need to find u because u is what I'm looking for, right? But I got some other expressions, so it's kind of getting messier. But guess what? Don't worry, we're going to be able to handle this. First of all, notice that we do know the sum. The sum is 9. So what I can do is I can actually go ahead and replace this with 9. And then let's see what we're going to get from here. We got a radical something square root, the sum of square roots. So let's go ahead and do that. So 2 times the square root of x1, x2 plus, and I can do, what I can do is I can kind of take out the 2 here. And let's see what we're going to be getting from here. Okay, so this is going to be isolated and it's going to equal u squared minus 9. Now what I can do is I can actually go ahead and, divide both sides by 2. So that's going to give me the square root of x1, x2 plus the square root of x1, x3 plus the square root of x2, x3 is equal to u squared minus 9 over 2. Awesome. Now, what I'd like to do is, I was trying to solve for something radical, and then I got another radical, but it's in terms of u at least, and I know what u is, so I can always go back and relate. What I'd like to do at this point is just go ahead and take this and square both sides again. All right? Cool. This is going to get more and more interesting as we go. Now, when you square this, it's kind of like, again, a plus b plus c, so let's go ahead and keep track of things here. It's going to look like a squared plus b squared plus c squared, right? Plus 2ab. Now, when you multiply these two quantities, notice that square root of x1, square root of x1 makes x1. So you're going to get something like this with the 2, of course. So let's go ahead and take the 2 out early on. And what we're going to be getting from here is like x1 root x2, x3. And it's just going to repeat. That pattern is just going to repeat over and over. So it's going to look like this, okay? And don't worry, we're going to handle this, all right? So we're going to be getting something like this, and that is going to equal some quantity, u squared, u to the 4th power, so on and so forth. We can deal with that later. Let's go ahead and simplify this guy first. First of all, notice that you do know the value of this one, because remember, initially we wrote those values, and so that's equal to 24. Nice. So we know that this is 24 at least, but do I know what's inside the parentheses? I don't, but I'll find out. How? Here's how we're going to do it. So this part is 24 plus. Now what I'd like to do here is inside the parentheses, I have like a radical expression, but all these terms have a common factor. And that common factor is square root of x1 times x2 times x3, which is cool, with the 2 outside. So I'm going to pull this guy out as a common factor. And inside the parentheses, what should I be getting? Since I took out all the radicals, x1 is going to be square rooted. So I'm going to be getting square root of x1 plus the square root of x2 plus the square root of x3. Awesome. Does that look familiar? Yep, that's our u. Okay, so this is u. All right. And I know x1, x2, x3 is equal to 16. Beautiful. So this is going to be the square root of 16, which is 4, right? So I have 2 times 4 there. So simplify this a little bit more. So that's going to look like 24 plus 8u, which is pretty good, right? I mean, a lot of improvement. And that is equal to this guy here. What is that? U squared minus 9 over 2 squared. So we're going to set this equal to, because it was initially equal to that, right? But I wasn't just using it. So let me write it that way. And then in the next step, I'm going to simplify this. So if we can solve this equation, we're good to go. All right, let's see how this goes. Oopsies, there's no room. So what I'll probably do is, looks like, since I have a lot of room, let me try something here. I don't know if I can do that, but hopefully I'll be able to do it. If I can, that would be real nice. But unfortunately, it doesn't allow me to do it, so never mind. So what I'd like to do is then, you know what? I'm just going to ignore this and continue to solve it, and then later on we can just go back and take care of this. So I think one of the things we can do here is, even though it doesn't allow me to cut and paste that part, I could probably do this part. I should be able to. Right? So let me go ahead and bring this down here and even more so that we have room for the last problem, and that would be the last problem. Okay, so we're almost there. Hang in there. I know this video is kind of long, but I had to go over some notes, and then hopefully this will be beneficial. And I don't know how far do I have to go down, but let's go ahead and stop here, and we can just start solving this. And don't worry about this one here. Okay, cool. So what am I gonna do? we're going to basically square both sides. So let's go ahead and do this. This is 24 plus 8u. When you square, you're going to get a 4 there. So let me go ahead and put that down here. And then I need to square the top, which is u to the 4th minus 18u squared plus 81. Awesome. So what I'd like to do next is basically, I would like to, just put it all together. U to the 4th minus 18u squared. Okay, so I'm going to be getting 32u from there. So I would like to bring that over here, minus 32u. And then we have 4 times 24, which is 96. If I take out the 96 and, just subtract it from 81, 96 minus 81 is going to be 15, right? So that's going to be a negative 15 right there. Alrighty, hopefully this is good. And the whole thing is equal to 0. Now, at this point, you might be thinking like, how on earth am I going to solve this problem, right? It looks complicated and it's quartic. Well, here's one thing that I'd like you to recognize. Okay, if you look at this equation carefully, all right, you'll probably notice a couple good things about it. First of all, if you look at the powers that are even, such as I have the coefficients, in other words. So, okay, the coefficient of u to the 4th is 1. The coefficient of u squared is negative 18, and the constant term is negative 15. If I add those, 1 minus 18 minus 15, I'll get negative 32, which means that is equal to the coefficient of the odd power terms, which means u equals negative 1 is a possible solution. Okay, cool. Since u equals negative 1 is a solution, then I have to deal with a cubic, which is kind of easier. So what I like to do is, and you can always verify this by substituting u equals 1 here. So 1 plus, oh, that's not plus. 1 minus 18 plus 32 minus 15. This should give you 32, 33, and 0. Cool. So u equals negative 1 is a solution, obviously. Let's go ahead and work this out a little bit instead of doing the polynomial division. I'd like to take care of this like... Okay, let's see. Since that's, I could probably just get away with, let me try this. I haven't tried it before, so I don't know if it's going to work or not, but we'll see how that goes. So I'd like to do it that way, and then I think I can get away with this. Nope, it should be a minus sign, I think, here. So let me see if that works. Minus 17u, that should give me a negative 1. But then I have a negative 15u left. Ooh, yay, it's working. Nice. Beautiful. I love it. Okay, great. So now what I did was basically kind of break it down so that each group has a factor u plus 1, because I know that negative 1 is a solution. Okay, hopefully that wasn't too complex. And I can just now break it down like this. Okay, u plus 1 minus 15, u plus 1. Good. Now I can just go ahead and take out u plus 1, and u plus 1 out is going to give me what? U squared times u minus 1, that should be u cubed minus u squared. And then this guy should give me minus 17u, and this should give me a minus 15, and that should be it. I know that u equals negative 1 is a solution, and I can just go ahead and plug it in, but obviously there's the sum of the square roots is not going to be that, so I'm going to ignore that one and focus with the other equation. Now, what am I getting from here? Well, okay, cool. So I'm getting a little easier equation, but can I check for possible solutions? Like, is 1 a solution? Okay, one of the things that I should check first. How about the negative 1? Negative 1 minus 1 plus 17 minus 15. Wow, that's kind of interesting, isn't it? Well, it's not a coincidence, obviously, but anyway, you notice that u equals negative 1 is still a solution here. So what I can do is I can manipulate it further. So what I can do is maybe like write it this way, and then write it like this. And then what am I doing? 2u, and then, does that gonna work? Nope, it's supposed to be negative 2u, right? Happy birthday to you, like this. And then I can write it as minus 15u minus 15. Sorry about the length of this, guys. Sorry, it's taken a while to figure out. But u squared times u plus 1 minus 2u times u plus 1 minus 15 times u plus 1. We're almost done with this, and we're going to find u, and we'll be done by then. So now I take the u plus 1 out again. I get u squared minus 2u minus 15. Again, I'll discard this and focus with this one. And this one gives me u minus 5 times u plus 3. is equal to 0. And from here, yay, successfully, I was able to find u, which is the square root of x1 plus the square root of x2 plus the square root of x3, which is equal to 5. And that's our answer. All right, awesome. Let's go back to the last problem, which was number 6. Here we go. We're almost done, so just hang in there and stay tuned. All right. The roots of the equation are r, s, t, u, and v. Of course, this is a quintic equation which can't be solved, unfortunately, in the general case. It's very sad. And they're asking us to find the fifth powers, the sum of fifth powers of the roots. Are you crazy? Okay, but this can be done in an easy way. Okay, don't look for any way to factor this because this is kind of like very crazy. We're going to use a really cool method. Let me go ahead and finish it up real quick. I don't want to drag this any longer. So here's what we're going to do. Since this equation is given like that, I'm going to isolate x to the fifth. And since r, s, t, u, v are each solutions or roots, what I can do is I can replace x with r. So r to the fifth is going to be 4r minus 2. S to the fifth is going to be 4s minus 2. T to the fifth is going to be 4t minus 2. And then u to the fifth is going to be 4u minus 2. And v to the fifth is going to be 4v minus 2. So I'm interested in the sum of these fifth powers. Therefore, if I just add, whatever I'm looking for is going to equal 4 times the quantity, and I'm ignoring that part, of course, r plus s plus t plus u plus v minus 5 times, oopsies, 5 times 2, which is 10, right? So this is what I'm looking for. But guess what? I was trying to find the sum of fifth powers, but I ended up with the sum of r, s, t, u, v. But that's easy to find. Look at that. It's negative b over a, and b is 0. Awesome, beautiful. Don't you love this? This is 0, and the answer, what I'm looking for, which is r to the fifth plus s to the fifth plus t to the fifth plus u to the fifth plus v to the fifth is equal to negative 10. And that's the end of this video. I hope you enjoyed the video. Please comment, let me know what you think, and I'll continue to make videos like this and puzzles and algebra, challenging algebra problems, of course. See you in the next video tomorrow. Take care until then. Bye-bye.